What if I told you there's a monster lurking in the universe so colossal it makes our sun look like a single grain of sand? What's the biggest thing you can imagine? A mountain? A planet? Our entire solar system? Well, prepare to have your mind completely blown. Today, we're diving headfirst into the cosmic abyss to find the largest black hole ever discovered. This isn't just big, it's a universe eater. Stick around and don't forget to like, subscribe, and hit that bell, because you won't want to miss a second of this cosmic journey. All right, let's set the stage. We're all familiar with black holes, right? These incredibly dense objects with gravity so strong that nothing, not even light, can escape. They're born from the collapse of massive stars. But we're not talking about your everyday run-of-the-mill stellar black holes. Those are tiny in comparison. We're talking about supermassive black holes. These are the titans that reside at the center of most, if not all, large galaxies, including our own Milky Way. Our galaxy's black hole, Sagittarius A, is a beast in its own right. It has a mass of about 4 million times that of our Sun. Imagine trying to cram 4 million suns into a space not much bigger than our solar system. That's Sagittarius A. It's huge, powerful, and governs the orbits of all the stars in the Milky Way. For a long time, we thought that was the pinnacle of cosmic bigness. We were wrong. So wrong. Astronomers started finding bigger and bigger supermassive black holes in other galaxies. We found black holes with masses of hundreds of millions, or even billions of solar masses. These were the new heavyweights. For example, the black hole at the center of the Messier 87 galaxy. The first one we ever took a picture of clocks in at around 6.5 billion solar masses. That's over 1,500 times more massive than Sagittarius A. Its event horizon, the point of no return, is so vast that it would stretch far beyond the orbit of Pluto if it were placed in our solar system. Light would take days to cross it. Think about that. Light, the fastest thing in the universe, would need days to travel across this single object. But even M87's black hole is just a stepping stone. As our telescopes got better and our survey techniques more advanced, we started discovering what are now known as ultramassive black holes. These are the absolute Goliaths, the 1%ers of the black hole world, with masses exceeding 10 billion times that of our Sun. And that brings us to the current champion, the undisputed king of cosmic monsters, a black hole named TON 618. Just saying the name sends a shiver down your spine, doesn't it? TON 618 isn't just a black hole, it's a quasar. A quasar, or a quasi-stellar radio source, is an extremely luminous active galactic nucleus. In simple terms, it's a supermassive black hole that's actively and voraciously feeding on a massive amount of gas and dust. This material forms a huge swirling accretion disk around the black hole. As the material gets closer, friction heats it up to incredible temperatures, causing it to glow with the light of trillions of stars. TON 618 is one of the brightest objects in the known universe, outshining our entire Milky Way galaxy by thousands of times. How massive is it? Are you sitting down? The estimated mass of the black hole in TON 618 is a staggering 66 billion solar masses. Let me repeat that, 66 billion times the mass of our Sun. Let's try to put that number into perspective, although our human brains aren't really equipped for it. If our Sun were the size of a golf ball, Sagittarius A, our galaxy's supermassive black hole, would be the size of a large school bus. Following that same scale, TON 618 would be larger than Mount Everest. This isn't just a black hole, it's a gravitational god. So, how big is it physically? The event horizon, that surface of no return, is estimated to have a radius of about 1,300 astronomical units. An astronomical unit, or O, is the distance from the Earth to the Sun. So, the radius of TON 618 is 1,300 times the distance from us to our star. Its diameter would be 2,600 astronomical units. Our entire solar system, out to the farthest reaches of the Kuiper Belt where Pluto lives, is like 50 astronomical units across. Our solar system would be a tiny, insignificant speck rattling around inside this cosmic behemoth. The Voyager 1 spacecraft, our farthest-flung emissary, has been traveling for over 45 years and is only about 160 astronomical units from the Sun. It would take Voyager centuries just to cross the radius of TON 618. This black hole is so massive that it challenges our theories of how black holes grow. How does something get so big? Stellar mass black holes are formed from dying stars, but there's a limit to how big a star can be. So, you can't just form a 66 billion solar mass black hole from a single star collapse. The leading theory is that they grow through a process of mergers and accretion over billions of years. Imagine in the early universe, galaxies were smaller and closer together. They collided and merged frequently. When two galaxies merge, their central supermassive black holes will eventually sink to the center of the newly formed, larger galaxy. They'll orbit each other, emitting powerful gravitational waves, and eventually, they too will merge, forming an even bigger black hole. Repeat this process over and over again for billions of years, and you can start to build up some serious mass. Alongside these mergers, the black hole is also constantly feeding. Like we see with TON 618, it's pulling in vast clouds of gas, dust, and any unfortunate stars that stray too close. This process, called accretion, adds more and more mass to the black hole over cosmic time. TON 618 is so far away, over 10 billion light-years that we're seeing it, as it was in the very early universe. This means it managed to grow to this absurd size in just a few billion years after the Big Bang, which is incredibly fast in cosmic terms. This rapid growth is a major puzzle for astrophysicists. It suggests that perhaps black holes in the early universe had a head start, maybe forming from the direct collapse of massive gas clouds rather than from single stars. Could there be even bigger black holes out there? Almost certainly. TON 618 is the largest we've confirmed, but the universe is a vast place. We've only surveyed a tiny fraction of it. There's a theoretical upper limit to a black hole's size, sometimes called the stupendously large black hole, or SLAB, which could be around 100 trillion solar masses. Above this limit, the accretion disk itself would become unstable and fragment into stars, effectively starving the black hole and stopping its growth. But even getting close to that number would be mind-boggling. We've already found another candidate, the quasar J2157, which might harbor a black hole of around 34 billion solar masses, also in the early universe. It's clear that these ultramassive black holes were more common back then. As we look out into the cosmos, we are essentially looking back in time. The light from TON 618 has traveled for over 10 billion years to reach us, so we're seeing a snapshot of a young, chaotic, and violent universe where these monsters roamed and feasted. Today, in our more mature, calmer cosmic neighborhood, the feeding frenzy has largely subsided. Most supermassive black holes, like our own Sagittarius A, are relatively quiet and dormant. They've eaten most of what's nearby and are now on a much stricter diet. But the giants are still out there. TON 618 is likely much, much bigger now, having had another 10 billion years to grow. We just can't see its current state because the light hasn't had time to reach us yet. Who knows how large the true record holder is right now, somewhere out in the unobservable universe. Thinking about the scale of TON 618 really puts our own existence into perspective. Our planet, our sun, our entire galaxy, they are all dwarfed by this single object. It's a humbling reminder of the sheer scale and wonder of the cosmos. We live on a tiny rock, orbiting an average star in a fairly standard galaxy, and yet we have the capacity to look out and comprehend these cosmic titans. We can measure their mass, calculate their size, and theorize about their formation. That, in itself, is pretty incredible. From the quiet giant at the heart of our Milky Way to the roaring, universe-outshining quasar TON 618, the study of supermassive black holes pushes the boundaries of our understanding. They are the ultimate cosmic monsters, the engines of galactic evolution, and one of the deepest mysteries in the universe. TON 618 currently wears the crown. A black hole so large it bends not just space-time, but our very comprehension of size and scale. So, the next time you look up at the night sky, remember what's out there. Beyond the familiar stars and constellations, lurking in the deepest, darkest corners of the cosmos, are monsters. Monsters like TON 618, a black hole with a mass of 66 billion suns, a true king of the cosmos. Thank you so much for joining me on this journey to the edge of imagination. What do you think? Could there be even bigger black holes hiding out there? Let me know your thoughts in the comments below. And if you enjoyed having your mind expanded, please do me a huge favor and hit that like button, subscribe to the channel, and ring that notification bell so you never miss another cosmic adventure. Thanks for watching, and stay curious.